to see the period of a pendulum. So here we have a pendulum, something like this. So moves like this, like this. The period, remember that is the time it takes to complete a round. So it would be, for example, from here. This would be the period. Half a period would be from here to here, something like that. And we will see that it's not depending on the mass itself. It will only depend on the distance or the large of this rope or this string, whatever it be. So yeah, also it will depend obviously if we are, for example, here, but for just a few degrees of movement, that is here or a little bit here or here, mostly if it is perpendicular, for example, to this table, it will only depend on this. And the formula is the period is equal to 2 pi times the square root of the quotient of the length of this divided by the gravity acceleration. So let's suppose that the length is 4 meters. Then the period, that is the time that it would take to that this pendulum complete one round, would be 2 pi times the square root of 4 over e, or 4 pi over times the square root of 1 over e, whatever it be. Now, here as you can see in the formula we have not involved the mass. Let's say now we have a pendulum and this measures 3 meters. So which one will take more to complete this, that is the round, so that is which one will have a greater period? It would be this one, because intuitively you can see it. If this is larger, it will take more to complete one cycle than this. But also in the formula you can see it. Here the period is proportional to the square root of the length. So here would be square root of 4 versus square root of 3. Square root of 4 would be a higher number than square root of 3, so the same thing. It doesn't matter if here we have a ton of mass and here just 1 microgram or whatever, it doesn't matter. Now, let's say that we want to find the length. That is, let's say that now we want to find how much does the length of the pendulum has to be in order that it takes only 1 second to complete the round. So that is that the period be 1. So stop the video and try to calculate it. So we want to find the large of the pendulum. So we have period over 2 pi is equal to the square root of L over the acceleration of gravity. We square both sides and we have the period square over 4 pi square is equal to the length divided by the acceleration of the gravity, and we have that the length is equal to the gravity times the period square divided by 4 pi square. So when the length of the pendulum is this stuff, this number, then the length will make that the period takes just once. Now, because we are saying that the period will be 1 second, we have that the length will be just g divided by 4 pi square. So you can remember that the formula for the period of the pendulum is 2 pi times the square root of the length divided by g. This is the same as the length is equal to g times the period square divided by 4 pi square. But now the question was, how much does this string has to be on length in order that the period be 1? So the period be 1 second, then we have that the length would be g over 4 pi square. And now just let's check the units. here we have period is on how many seconds does it take to complete a round. So here we have units of time. So second, for example, second. This doesn't have any units. We have the square root of length is meter, and acceleration of gravity is on meter per square second. So here, remember, we have a convenient one. We kill these meters, and we just have a square. We have second is equal to the square root of the square second. So we already checked that the units are correct. And so this was just to make you comfortable with the formula of the period of the pendulum, that is 2 pi times the square root of the length divided by the acceleration of gravity.